Hello and good afternoon. So here's a video by Bud Churchward, and he's using an LM567 and experimenting with it. So I'm not going to try and recap everything he discusses, but I did bring it up just so you could see his schematic diagram as to how he hooked it up. Alright, so I hope Bud doesn't mind. I hope he actually takes it as a compliment that I tried to build one of his circuits, but I just wanted to show the modifications that I made to the schematic. So I took out the one LED and I added a 1 microfarad capacitor from pin 4 directly to ground. And this is the capacitor here. So here's pin 4, and it kind of solders onto the back of the board, but it goes directly to ground. This is ground. And I'm using a potentiometer that turns by hand rather than a digital potentiometer. And I added some of these terminal jacks as well. Please take a look at my channel, as I made a video on the data sheet for the LM567. So that's this video right here. And I recorded myself learning phase detection and phase locked loop. Now this is me learning it for the first time, so by no means am I an expert. But it kind of relates to the LM567. Here are the integrated circuit chips as I got them in the mail this past week. These are LM567s. When I went into the data sheet for this chip, the Texas Instruments data sheet, this was an example of an AC test circuit, and I built it on a breadboard and it worked. I was just having some trouble getting the circuit to detect the input signal. I might work on that. If I can add a recommendation, if you're trying to build a circuit, whether it's the Bud Churchward one or this one here, it's better to use lower value trim pots, maybe 2K, because 10K is quite a range. Another thing I did is I have a logic probe, and you hook the logic probe up to the VCC and the ground pins on the circuit, and as you probe things with the tip on the circuit, you can detect highs and lows. And why that's interesting and important is for probing pin number 8. So if you're troubleshooting your circuit, one of the things you probably want to check is that when you jumper from pin 5 to pin 3 to create a match signal between the input and the internal oscillator, that should be putting pin 8 at low. Well, if you have a logic probe, you can test pin 8. In my case, the logic probe green light goes on when it detects a low signal. Okay, here's my setup. You'll see in the video in a minute, but this is my power supply. The minimum and maximum recommended voltages for the LM567 is somewhere between 5 volts, I think, and 9 volts. I set my power supply at 6.2 volts. Here's a signal generator, and I've got like a sine wave, triangle wave, and square wave. And this is an op-amp circuit inside here, and I just built a case for it, so it's an amplifier. And What I'm really amplifying is I'm tapping into pin 6 and ground. So just take my word for it. I've got pin 6 going into the amplifier, and then the white line is ground.
Hello and good morning. Thank you very much for watching my video. Today I'd like to demonstrate how I got my LM567 chips hooked up and working. There was a YouTube video by Bud Churchward. I hope I'm saying his name correctly. And this is generally the schematic that he used in his video for testing out the LM567. His experiment was a little bit different. He was using an Arduino and a digital potentiometer, and there's a little bit more to it I won't explain. But I hooked up the schematic almost exactly as he has done, and just as he did, he actually left this second diode out. As far as this capacitor here, I made this a variable potentiometer at 10K, which maybe wasn't the best choice. If you're going to rebuild this circuit, maybe a 2K pot might be better. And also, what else did I do that was a little different? I used an electrolytic capacitor. Well, actually, I used electrolytic capacitors for all of these. I don't know if he did that as well. Of course, if you use those, you have to make sure they're the correct polarity. Anyway, what I have here is a signal generator kit, which I built, I don't know, a couple years ago. And you can choose between square and triangle and sine wave, and each one of these different lines here is that, and the white one is actually ground. And then there's a potentiometer here where you can change the frequency tone up and down. If I hook the signal generator directly up into this op amp, which I put in a kit box I made myself, then you would be able to hear it. But right now you can't really hear it unless you amplify it. Now I should maybe talk about the LM567. Again, I have it hooked up exactly as the schematic here. I had to divide it up between this PCB and this board here simply because I was running out of space on the PCB. So the capacitors don't need much discussion. You can see them all there. Oh yeah, in this circuit there was no capacitor back to ground in the Bud Churchward schematic, so I actually added that in here. The data sheet said 1 microfarad back to ground off of VCC, so I added that in to the schematic. Here I used a 10K pot. It was almost a little too much. And then this capacitor here is part of the resistor capacitor circuit that controls the internal oscillator of the chip. So the capacitor is this one up here, and this R3 I chose as a 10K trim pot, that's here. So this board here is pretty much just this section of the schematic, and then I added these little sockets, these little green sockets, just in case I want to experiment later with an Arduino or something like that. So that's what that would be if I want to tap off the oscillator circuit, the RC circuit. I'm going to try and show this. I wanted to demonstrate something on camera, just in case you watching are trying to get one of these ICs hooked up and working. So on this IC, here's pin 5, here's pin 6. Again, my RC circuit is hooked up separately, and it's kind of deciding what the internal oscillation is. But if you want to test your circuit to see if it's working, you can tap off of the oscillator. I think it's pin 6. If it's not pin 6, it's pin 5. And then you can just touch it back on pin 3. Okay, I'm wrong. It's pin 6. So basically, you're tapping into the internal oscillator, and then you're sending it back into the device on pin 3. Now, why the LED light is going on is because that's hooked up to pin 8. And basically what's happening is that the oscillating signal, which is this one here, being sent back in on pin 3, is showing that it's a match. And it should be, because it's the same signal. So when the signal on pin 6 and pin 3 are a match, it'll send pin 8 low, and without too much explanation, the LED is hooked up to pin 8, also with a power supply from VCC through a resistor. And so when pin 8 goes low, it basically makes a complete circuit. Inside on pin 8, if you look at the data sheet, there's a transistor back to ground, and this is an open collector. So the open collector is going through the LED. It's a little bit technical, but if you study the data sheet, it should be clear why the LED is going on when pin 8 is actually being sent low. So again, pin 3 and pin 6. So that's how you can test it. You don't even have to hook up an input signal. You just want to test and see if it's working. Now pin 2, which I didn't really discuss, that's going to determine the band frequency. So if you had a variable capacitor, you could maybe hook it up to pin 2. Of course, you'd have to look at the data sheet and learn a little bit on how to pick the appropriate capacitor value, but that's a different discussion. So I'm just going to show that this works. I already have the signal generator dialed in to a matching frequency as to that of the resistor capacitor circuit going into the oscillators on pin 5 and 6, and out of the internal oscillator, I've got that hooked up to an op-amp circuit. This is just an amplifier. When you do that, and you hook it up to an amplifier, just as I have done, you will actually be able to hear the signal coming out of the signal generator in addition to the signal that the internal oscillator is generating. So you can get some really weird noises. Okay, well, here I go. I'm going to turn the speaker on my op-amp. My off is on and my on is off. You'll see. Ooh, that's awful. Turn that off for a second, just so I can talk. Oh, I forgot to hook up the signal generator. 2 seconds here. So watch the twisting of my fingers. I don't know how evident it is. And you can see as I sweep through the band, which really is adjusting the oscillator inside this, the light goes on when there's a match. Okay, well, hopefully that explains it. And I don't think I'm going to try to cover much more information, but I did have a whole lot of fun just making different noises. Oh, I guess maybe I should mention one more thing. Rather than adjusting this knob here, I could probably adjust the this knob here on the signal generator, which sweeps the frequency up and down. That could have been an option too. But for the rest of the video, allow me to make some awful noises. This one almost reminds me of Doctor Who, where you can sweep through the frequency. I better turn this on. Okay, let's try a different wave. So this was a sine wave. Let's try the square wave. And maybe the triangle wave. Let's try that.